Hi everyone, part 4, modeling data with a curve of best fit. The material in this part is almost identical to that of part 3, except it deals with quadratic and cubic functions, which do not form straight lines. The process for finding the regression equation will be the same, however. So this is the investigation from page 307 in the Principles of Mathematics 12, this is your textbook. So, Damien's physics class measured the height of a bouncing ball in the school gymnasium. The ball was repeatedly dropped from the same height. The height was recorded every 0.2 seconds with a special camera, starting with the very first bounce. The data is shown in the tables below. So we had 3 separate trials, all good. Okay, and the first thing is to create a scatter plot by plotting the data from all 3 trials on the same grid. You may use technology. Well, that's a good thing, because if we plotted all those, it's 18 points. That's a lot going on there. So remember, what we're going to do, the time is the x-coordinate, or the independent variable. So we're going to put time in list 1 and the height in list 2. Okay, so we're going to type that all in. Now you guys know how to do that from the previous examples. It is under the Stat Edit button. Okay, so if you have a look, so you go Stat Edit, you get to this menu. Okay, I still had those old lists from the last part in there, so I just wanted to quickly recap. This is in that document on how to do regressions, but we still wanted to talk about it. Okay, so if you select L2 and then go clear enter, it'll actually erase whatever's in that list. So then go up to L1, clear enter. You don't have to clear all the lists then, or like it just works nice. Okay, anyway, so then you enter your data from there. So there's the first 10 points, here's the second 10. Okay, now this is the part that we didn't really do in section 3. Part 3, they were all straight lines, so we didn't have to plot them. We just knew they were a line. So now this is either going to be a quadratic or a cubic. And how we can tell is quadratics are symmetrical with the bumps. Okay, very symmetrical, whereas cubics aren't that way at all. Okay, so we should be able to tell once we have them graphed. Okay, so how we do that, remember, to turn on the stat plot, go second y equals, which is the stat plot. Okay, select the first one and then select the on button right there. So that turns the stat plot on. Remember, the scatter plot is the default, but for whatever reason, if yours isn't on the type, that first one, make sure that it is just by hitting enter on it. Okay, and then once you've got all of these, again, these are the different marks. So if you want to have the plus signs instead of boxes, that's completely up to you. It's all good. Then once you're finished with this screen, hit graph. Okay, and what graph does is it makes the plot. Now on a standard window, you would probably only see something like that. Okay, not very big, not very whatever. So here's the window setting I used. So if you want to change your graph to that window setting, then you will see kind of a similar graph to what I've got going on there. Okay, so I know that was a lot to absorb all at once. You probably haven't even typed the data in yet, but okay, so go ahead and press pause and then type your data in. Make sure you get the same dots that I got, and life will be good. Okay, so let's pause. Oh, you're back. Yay. Okay, awesome. So what we're going to do now is, now that you have your data in there, we can see from the way the data looks, this is very much a parabola. That looks symmetrical. Okay, that is definitely a parabola. This is definitely a quadratic. So the thing is, what we want to do is we want to get that quadratic regression then. Okay, awesome. So what we do, and I didn't copy that picture, so I'm going to go back a few pages just so you can see. So when you go to the Stat Calc menu, okay, so you go to Stat Calc, and then if you look at number 5 down, it is the quadratic regression instead of the linear regression. So go down to the 5th one, that gives you the quadratic regression for this stuff. Okay, and the quadratic regression works just like the linear. You press enter 5 times. Ooh, enter, there we go, 5 times. Okay, and then what that does is that gives you the quadratic equation there. Okay, again in the form y equals ax squared plus bx plus c. So, and the question asks for the nearest hundredths. So if we look at that again, that's y equals, okay, so negative 9.79x squared plus 10.01x. Okay, and I want to draw your attention to this last part. Because look at this, 7.14, and then this e, remember, that's the symbol for the scientific notation thing. So really 10 to the negative 4 is, so negative 1, negative 2, negative 3, and then negative 4, the 7 starts there. So rounding to the nearest hundredth, that's 0.00. Which, so really I could write 0 if I wanted, or 0.00, but I don't have to. And this should make sense to us because the time, we don't start the camera until the first bounce. So when it bounces, the time is 0 as it's hitting the floor. So the height should be 0 when the time is 0. Right? The constant term should be 0. So we're good with the equation the way it is. Okay? Now, here's the thing. It says write the domain and range. Okay, the domain is really easy because this is a parabola, which is a polynomial, which means that x is an element of the reals. That's just the way all polynomials work. However, we know that the graph kind of plotted out like this. Okay, and it stops, of course, at the floor. Okay, so we need to figure out this maximum point for our range. Okay, now the first part of the range is easy because we can't be any less than 0. So our height has to be bigger than or equal to 0, but then smaller than or equal to whatever that maximum point is. So this is where we use our calculator to do this for us. Okay, how we go about doing this is we go to the y equal menu. Okay, so y equals, did I put that up here? No, I didn't. No, I didn't, sorry. Okay, okay, so the y equal menu. Okay, and from there, okay, so in y1 or wherever you are, okay, hit the vars button. Vars is 3 up from the 9 key. So once you hit the vars button, what ends up happening is, remember, all these stat things, those are statistics. Okay, so if you look on the vars menu, the 5th one down is statistics. Now remember, this is also in that instruction booklet we made for you for regressions. So you can refer back to that. But anyways, so once you hit the statistics on that, scroll over twice to EQ. EQ, and then you notice the first one there is reg EQ. So that's the regression equation. So if you hit enter on that, what it does is it populates this equation into y1. And not just that equation, all the decimals with that equation. So very, very accurate. Okay, so when you do that, then of course you have the plot, and then when you hit graph, it actually graphs the parabola as well, which lets you figure out that maximum point. So remember, to do that, we go second calc to get into that calculate menu, maximum, and then lower bound, upper bound. This is a review of Math 20, so you should know that. If you don't, ask your teacher because they'll be able to help you better. But remember, press enter when you're lower than the point you want. Scroll over to the right of the point you want, hit enter again. What that's doing is you're giving the calculator a range that you want to find the maximum in. Okay, when you do that, you get a maximum value of 2.53. So that is how we figure out the range. So the range is from 0 to 2.53. Perfect. Okay, I know that was really long-winded. Sorry, you probably know a lot of that already. But you know what? It's my job to make sure you do, just in case you didn't. All right, so that's the first one. So all my little notes there. So let's look at this example with the box. So a box with no lid is made from cutting 4 squares of side length x from each corner of a 10 by 20 rectangular sheet of metal. Okay, so we're going to take this x little corner out, and then we're going to fold up the sides to make this box. Okay, so again, we're just going to fold them along. Well, I'll make the blue line solid just so you can see them better. So that blue rectangle in the middle, that's going to represent the base. Whoa, that was weird. Okay, and then we're going to we're going to cut these corners out so they're not going to be there anymore. And then we're going to fold along those lines and make this box. Perfect. Okay, so the following table shows the volume of the box for various values of x. Okay, so these are what we're going to put in our stat lists. Okay, so the height of the box, that's going to be list 1, and the volume is going to be list 2. Okay, so I want you guys to type those in right now. When you do, you should end up with the list that looks like that. Awesome. Okay, so when you do that, again, we're going to go into the stat plot. Make sure you turn your stat plot on, okay, and then plot it up. Okay, when you hit graph for the plots, you don't see much right away. Well, the reason why you don't see much right away is the volume is quite high. Your standard window only goes up to 10. So the thing is, you'd see maybe the last point right there, but you wouldn't see any of the other stuff. So what I did is I went from, well, you can see my window setting right here. Okay, I went from -2 to +5 with a scale of 1, and then a y minimum of -2 up to 200. Right, the volume, the maximum is 188 from the list anyway, and we want to give it a little bit of room. So I said 200. Okay, and then when you do that, then you can see, oh, here's the window right there. Okay, so it looks not too bad. Now, what I noticed, or what you notice from here, from the plots, okay, this is not symmetrical. Okay, so this kind of looks like woo, and then kind of curves off. Okay, so not symmetrical, which leads us to think that this is a cubic graph. Okay, so, and of course it is a cubic graph. And you can also tell that because remember, like this is a long time ago, but volume is length times width times height. And we can make these expressions all in terms of x. But either way, this is going to give us some form of an x cubed function. Okay, so that kind of gives it away that it's a volume or a cubic function as well. So anyways, we do the same kind of procedure as we did before, except when we go into the Calc Edit menu, we want to do a cubic regression instead of a quadratic or a linear. Okay, so a cubic regression, and when we do that, we get to that one screen, press Enter 5 times again, and then you end up with this as your equation. So it's ax cubed plus bx squared plus cx plus d, and it says round to the nearest hundredth again. Okay, so we round to the nearest hundredth, and we end up with, so y equals ax cubed plus bx squared plus cx plus d. So that was 4.00x cubed minus 60.01x squared plus 200.01x minus 0.01. Awesome. Okay, so there is our equation. Okay, and what type of function? This is a cubic function. Okay, so determine the domain and range. Well, the domain, of course, is x is an element of the reals. And the range, well, the range is a little bit tougher because we have to go back to this graph. Okay, and this is where we do that y equals, then press the vars button and everything. Now, I did make those ones. So you go into the y equals, hit the vars button 3 above the 9, so we're into statistics. Okay, regression equation. Okay, and then that automatically populates our equation in y1 with all the decimals. It's beautiful. When you hit graph, you end up with this graph. Okay, so there's the plots, but you end up with this nice smooth curve. See how it's not symmetrical? Again, total giveaway that it's a cubic. Okay, and then we want to do the whole second calculate menu. So that's this guy, calculate. Okay, and we want the maximum value. So again, our calculator prompts us for a lower bound and an upper bound. So all we have to do is select points left and right of the maximum, and then it'll tell us what the maximum is. So you can see the maximum value is 192.45 when our x is 2.11. Okay, awesome. So it's 192.45, so we go back here. So we know that the range for this one, oh, and you know what, guys, I messed up with my domain, so I'm going to stop this. Okay, the graph of this thing, silly me. Okay, the graph starts at 0. Okay, now even though all polynomials have a domain of x is an element of the reals, okay, in this case, look what happens is it stops there. Now, the volume of the box can't be negative, like silly me, I'm sorry. Okay, but the domain goes from 0, right? If x is 0, then there's no side length to turn up. And the biggest x could possibly be is 5. 1, 2, 3, 4, 5. Okay, so our domain is 0 to 5. Sorry, silly. Okay, so 0, that's an x less than 5. Now let's go back up to this box and just kind of talk about that. Look, this is only 10 centimeters wide. So if our cutout is 5 centimeters, 5 and 5, then really we're folding this piece of sheet metal right down the middle, and we don't get a box, we get like an envelope. Okay, very strange. Okay, so that just doesn't happen. So that's why our domain is between 0 and 5. And then, of course, the range we said was this top part is 192.45. And, of course, the low part is 0. So the range here is 0 is less than or equal to the volume, which is less than or equal to 192.45. And once we're in there, of course, y is an element of the reals. And you know what? X is an element of the reals as well. So we can put that in there. X is an element of the reals. Y is an element of the reals. And there you have it. Okay, so I need you to practice this section. It starts on page 313 in your textbook. Okay. Now, in 3 to 9, I want you to choose one quadratic question and one cubic question just to make sure that you're trying the various things, okay, but not overloading you with too much work. So, good luck in this. This is actually the end of Chapter 5. So, lucky you. Awesome. And good luck on the upcoming assessments, and we'll see you next time. Thanks, everybody.